Chemical Science Made Simple. I am Wisdom Benjamin. Don't forget to subscribe to our channels and also share this video. In today's lesson, I'll be teaching you on how to name the compounds of alkanes according to the I.U.P.A.C rules.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air, oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for salty times, magnesium, aluminium, silicon, phosphorus, then sulfur, chlorine, then argon.
Alkanes are organic compounds with single bonds between the carbon atoms in the carbon chain. And because of these single bonds, alkanes are said to be saturated. They have the general formula of CnH2n plus 2. It's very important to know that in naming the alkanes, the first rule to consider is to establish the parent name of the alkane. And to do that, we must consider that when an alkane has one carbon atom, meth is used as a prefix. When it has two carbon atoms, we use it. 3 carbon atoms, prop. 4 carbon atoms, but. 5 carbon atoms, pent. 6 carbon atoms, hex. 7 carbon atoms, hept. 8 carbon atoms, oct. Down to 10 carbon atoms where we have the deck. Now, it's very important to know this so as to be able to establish the parent name of this alkane. Now, how do we establish the parent name of this alkane after we have known this? It is to count the continuous chain. We establish the parent hydrocarbon by counting the longest continuous carbon chain. For example, we have this. Now, from what we have here, we can see that this is 1, 2, 3, 4, 5. This is going to be a 5 carbon alkane. Now, where does it fall from what we just said here? We see it here, 5 carbon pent. Now, 1, 2, 3, 4, 5. When we fix our hydrogen atoms, as I'm doing right now, you can see all the carbons in the chain are tetravalently bonded as is expected. Now we end the name. We have established bent from the 5 carbon atoms that we have. We end the name with N, A-N-E, alkane, A-N-E. Therefore, the name of this compound becomes, don't forget that we have 5 carbon atoms here, pent. It becomes pent N. Pent N. Pent from 5 carbons and N from alkane. Secondly, we must note that an alkane can accommodate attached groups, which we know as substituents. And these substituents can take any position of their choice. Now, looking at the same number of carbon atoms we have in the chain in the example below, in the example we are written, we can see if we have the same 5 carbons, 1, 2, 3, 4, 5, our hydrogens are here, and then we have a particular carbon that carries a bromine atom. There's a chain here, and that chain only comes from this carbon. Here we have the pentane. It has hydrogen on it, the carbon there. But from here, we are seeing that bromine atom is now attached to this carbon. This bromine atom is known as the substituent. Now, we name the substituent by stating clearly their positions in the carbon chain. Now we have this bromine atom, And we must also look at the next rule that says we should give the substituent that we have seen the lowest possible number. What does that mean? When we count from left to right, this is 1, 2, 3, 4, 5. From right to left, we have 1, 2, 3, 4, 5. Now, what do we see here? From left, the bromine is at carbon 2. From right, the bromine is at carbon 4. Therefore, going from left to right, bromine will take the lowest possible number, which is 2. It then implies that this compound will have the name. Remember, we still have 5 carbon atoms, which still maintains our pentane as the parent's name. Then, putting the substance that we have, the name implies the position. Remember, we must name the position of the bromine atom that we have. The position is 1, 2. 2 at carbon 2, we have the bromine atom. Now, we use commas and hyphen to separate numbers and words respectively. 2. Bromine as a substituent is known as bromo. So I use hyphen to separate the 2, which is a number, from bromo, which is a word. Then I now put the parent's name, which is pentane. So the name of this compound becomes 2-bromo-pentane. Again, we use a carbon position twice to indicate the presence of 2 substituents on it. What does it mean? It means that this particular compound, or this particular number 2 carbon, can have more than 1 substituent attached to it. If it is bromine, for example, this hydrogen becomes bromine. We will use this position twice to indicate that there are 2 of such substituents on it. And a prefix will appear. We use di when there are 2 of such substituents. We use tri for some substituents. We use tetra when there are 4 of such. So the name of this compound will change, of course. And we'll have at carbon 2, of course, we're still following the lowest possible number for the substituent, which is from left to right. So this arrow will indicate where we count from left to right. Then at position 2, there are 2 bromines. 2, remember we said we separate figures or numbers with a comma. 2, 2, then a word is coming up, so we put a hyphen. Now, there are 2 of such, and we use di, because di represents 2. 2, 2, di. And what is that substituent? Bromine, and it comes as bromo. 2, 2, di, bromo. Then the parent name appears again, pentane. This applies to as much number of carbons in the carbon chain of the alkane. It can be done. It can be done for hexane, it can be done for heptane, it can be done for nonane, it can be done for decane. Just following the rules. And it's also very important to alphabetically arrange substituents. For example, when there are 2 or more different types of substituents in a carbon chain. Let's take a look at that example here. Now, let's go away from 5 carbon chain. For example, we have 1, 2, 3, 4, 5. Now, and we fill our hydrogens. Now here we have our bromine. Here we have bromine. Here we have chlorine. And then we have our hydrogen. We have a hydrogen. We have a hydrogen here. We have a hydrogen. Then here we have a methyl group. Here we have hydrogen. Then Let's consider all the rules that we have stated here in naming this compound. First of all, the number of carbons in the continuous chain. We count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3. Now we have 6 as the longest continuous chain. It means that the parent name of this compound will definitely fall on 6, which is hex. Now, we have substituents attached to this compound. We have 2 bromine on one particular carbon. We have a chlorine. We have a methyl group also attached to it. Then, where do we begin to count from? It's a very serious question, and we must be very careful in locating where we count from. Now, from left to right, 1, 2. At carbon 2, there are 2 bromine, 2 substituents. 3. At carbon 3, there's another substituent. So 2, 3 have about 3 substituents. Carbon 2 and carbon 3. Now let's go from right. From right, we have 1, 2. 2 has a substituent, which is methyl group. 3 has none. And then before we now get to the next 4. So counting from left to right, we meet more substituents than counting from right to left. So it's also very important to know that we give the lowest possible number to the side of the chain that has more of the substituent. So the name therefore implies at carbon 1 and carbon 2 we have 2 substituents of bromine. Remember, we use sorry, but I have to clean up this. 1, 2, and there are 2 of it in carbon 2. 2, sorry, 2, 2, there are 2 of it, dibromo. Then at carbon 3 we have a chloro, then we have hyphen. Remember, you separate words from figures with a hyphen. Bromo, at carbon 3 there is chloro, 2, 2 dibromo, 3 chloro. Then at carbon 5, because we are going from left to right, 1, 2, 3, 4, 5, 6. So this is our carbon 5 that carries a methyl group. This can be the methyl group or this. If you go like this, this becomes the substituent. If you go like this, this becomes the substituent. And the both of them are all in carbon 5. So after 3 chloro, we have, remember we are using alphabetical arrangement also to put our substituent. Bromo comes before chloro, B before C. And we said also that the prefixes di, tri, and tetra does not count. We don't consider it in this kind of arrangement. So we look at the particular substituent, B before C. So we would not say 3 bromo then before saying 2, 2 dibromo. That would be very wrong. Or rather 3 chloro before 2, 2 dibromo. No. We'll say 2, 2 dibromo because bromo comes before chloro. Then we can indicate our methyl. 2, 2 dibromo, 3 chloro. Then at carbon 5, we have our methyl 5 methyl. Is that the end of our substituent? Yes, of course, that's the end of substituent. We have just 3 types of substituents in this carbon, in this compound. So we have been able to indicate their numbers, their positions, and what is left now is the parent's name. Remember, we established that it's 6 carbon compound falling onto hexane. Therefore, we can add our hexane. 2, 2 dibromo, 3, 3, 2, 2 dibromo, 3 chloro, 5 methyl hexane is the name of this compound. Like I said, this can also be done. You can try this with other number of carbon atoms. You can have 5 or more, 6, 7, and you will see. By following these rules, you will, of course, arrive at a very good answer.
And calcium, so you'll grow strong. Scandium, titanium, vanadium, and chromium, and manganese. This is the periodic table. Noble gases stable. Halogens and alkali react aggressively.